All right. Hello and welcome to this third part in the ongoing series of lectures on PDFX workflow. So, in this lecture, let us just get a brief recap and review of whatever we learned in the uh, first two lectures. In the first part of the lecture, I just gave you the overview regarding some of the basic or origin story of PDFX and what is the meaning of this X in PDFX and the various versions, why they are different. uh, in the second part, we started our actual discussion on how a workflow should look like, and we also did some practical demonstration of editing those files, be it in Photoshop, Illustrator, or InDesign, putting them all together from putting all those Illustrator and Photoshop files into InDesign, creating the layout. We started doing all those things, but in this lecture, I initially had thought that this would be a three-part lecture, but I don't think I'd be able to finish up everything in this part. This is also maybe I'll take one or two more lectures in this workflow series. Nonetheless, let us start our discussion today and see. In this part of the lecture, we are going to primarily focus our attention on optimizing the layout. Ultimately, our goal is to export the PDF files. We'll see that in this lecture itself. But ultimately, before that, we need to, when all the elements have been together, and then what we need to do is essentially optimize the entire layout to make sure that the ultimately the PDF that is we are creating, that does not have any deficiencies. So I'll explain what I mean by those deficiencies. So today we'll start with the concept of how to various related concepts and various related techniques on how to optimize our layout for exporting PDF X files. And the second thing that we are going to talk about is some best practices in terms of transparencies. Because you see, transparency, we have made an entire, I think, two part video on that transparency also. So we know by now that how critical it is, how critical transparency handling and dealing with transparency, and most importantly, implementing the transparency can be. So that is why uh, I'll also try to focus or put some emphasis on some of the best practices that exist on applying and using or executing transparency in your files, in your layout files, right? So that part we'll do, and also we'll be starting our discussion on color management, some parts of color management also, and ultimately we'll be reaching the concept of how to export PDFX compliant files from your layout software. But before that, I also like to talk about, maybe before or after that, some at some point in time, I'd like to talk about refrying PDFs, that is the concept of PDF aggregation. So maybe what we can do is we can talk about aggregation of PDFs and the best practices there, whether it can be done or not. So all those concepts we can do during our discussion on the Ghent Output Suite version 5. So maybe because we will be individually taking up the patches, and then we can go ahead and create some idea about PDF concept of PDF aggregation. So now let us start our discussion today. See, some of the basic methods to optimize your layout should be focused on how the PDF is rendered, and not only rendered but rendered to the highest quality possible. When I mean layout optimization, I mean exactly this thing, right? Why, you may say, you may ask, this is important? Of course, because we know from the concept of live transparencies only that until PDF 1.3, when live transparencies were not allowed in PDF files, we know that they were we needed all the transparency that were in the layout to be flattened, is it not? And once they were flattened, and they would be flattened at maybe at the max, your line and vector would be flattened at 1200 dpi, right? But with the advent of PDF 1.4, when we started to use live transparencies in PDF files, that made our life a little bit easier, and simultaneously the advent of APP also, which helped the DIPs to take PDFs instead of PostScripts as their input. Now this also enabled us to render those transparencies or those effects at the highest possible addressable resolution of our CTP. So let us say if our CTP has got a 3200 dpi resolution or 2540 resolution, then instead of that 1200 dpi or 300 dpi at which we were flattening the transparency in our native design application, we could render those transparencies right at the highest possible addressable resolution of the CTP. This is a very big advantage, is it not? So that is why we need to understand the process through which we can ensure that something which does not need to be rendered, which is actually a vector or which is a text, how to use that, or how to ensure that only the images get rendered but the vector and the text they are recreated as solids now, or are treated as vectors as such. Now, in order to understand that, we also need to understand the concept of Z order. So Z order is something, it is talking about mm, uh, a stack of objects, right? So by now we know that we are working with various layers and various objects. At each layer we use different objects, different images, different artwork, what you may have. But simply put, the concept of Z order is the order of the object, of that specific object in the stack of all the objects. So where can you find the stack? Simply in the layers panel, right? So what I have done is I have intentionally created multiple objects and placed them in different layers just to explain the concept to you. So you see, the the top layer will be printed last. I mean, in front of all the other objects, right? And the bottom layer is at the back of all the objects. So this is the entire stack, and individual components within the stack, within the layer, are the objects that are present within each of the layer, right? Now there's another important concept that I would like to talk about. You should also make sure that, if I remember correctly, mm, in the transparency lecture somewhere, I think there was some, maybe in that the transparency group and all those concepts, the magenta was actually in the background, so it was the first down color, right? That means it was in the background of the entire image. But when we saw the stack of objects in our PDF, we saw that magenta was on the top, right? So this type of these are the certain mistakes that we often do, and we don't look for those mistakes. But ultimately, it's always a best practice to maintain the printing order in your stack order. A Z order should match your printing order or printing sequence. That is all I want to say in this context. Now, the idea over here is that, see, I have arranged it in such a way that your cyan is the, this is, let me check if it's 100%. Yes, it is 100% cyan only. So all of them are process colors except for this blue at the very end. This blue is I think a Pantone shade named color. So yeah, this is actually Pantone. Sorry. So this is, let me select this one. Yeah, this is the Pantone 1108 coated named color, right? Now, so as I was saying that the cyan is the first down color, right? So naturally this will be the last. This will have the last position in the stack. On top of it, we have the magenta patch, whose position in the stack is above cyan. Similarly for yellow, and as you can see, on top of everything, we have got this spot. This is the spot color which is to be printed last. So normally when we are going for a 5 color or 6 color machine, you would see that normally the spot colors are always printed in the end. I mean, before that you've got your KCMY, and following which you normally print. I mean, this order might vary, the sequence might vary because of certain situations the printer might face, but normally this is a general practice among printers throughout. Now that, so this printing sequence is matching your object stack order in the layers, as you can see. But what I wanted to focus here is, the moment you place the text matter, you see that this circle, this frame that I've put, this is something else. I'll explain it later on, but let us focus first on the text. So this text has got, I've given it a drop shadow, but this, ignore the drop shadow here for a minute. Drop shadow will come in context with this frame actually. So ignore the drop shadow here for a minute. So now let me just go ahead and remove this drop shadow once. So, yeah, so this is a simple text, right? So text, normally we don't want this to be rendered as an image. Actually, the ideal thing would be to, provide you with the separated separations. Actually, I mean, separations of an image, that is cyan separation, magenta separation. So when we are talking about text and the solid patches, so they will be rendered kind of the same because they are solid patches. But consider or imagine this to be some separations which are printed one after the other at different printing units in the offset machine. But the text is to be is not, does not need to be rendered into or does not need to be ripped into dots, right? It is a vector, it is a solid text matter. Now but ultimately this is in a transparency group. So if there are certain elements to it, then this becomes in a transparency group. So let us put both these things together, that is the yellow and this thing, and let us make them a multiply group, right? So maybe I'll make this as a knockout group, right? Okay, so this I've made this into a knockout group. So this text is in contact with this knockout group, transparency group. Now the question is, as soon as this knockout group or this transparency group is to be rendered, right, by the read, so will this text matter. In order to avoid this from happening, first of all, what you need to do, that thing I'll tell later on, but one thing that you always must do is put the text matter which you don't want to be rendered the same way as your transparencies, put that in the topmost position in the stack of objects in terms of the layer. So as you would see that here the text is presented, or text is present at the top of the stack. The purpose of doing this is because our new versions of PDF supports OCGs and all, this position of the text would be recognized, and it would, during ripping, this would not be interfering with the process of rendering this text would not, or the process of rendering the transparency here would not interfere with the text here. So text will be rendered as a solid, or as a text or a vector kind of a thing, right? So this is quite important for us to understand the importance of positioning the text. So let us say that you have got a image, a transparency, and a text. So the ideal method in that situation should be to put the text as a sandwich between the image and the your transparency based frame. So if you have got a image, so normally you put the image at the in the top layer, you put the text below it, and then at the bottom layer you put the frame that you have got the transparency effect. So this will ensure that the text is rendered as such, and it's not interfering, or that rendering of the transparent objects or groups, that will not interfere with the rendering of the text matter. So this is quite important, the understanding the Z order, and understanding how you would optimize your layout in order to get the best possible outcome. So what is going to happen, you see, if you're even if you're wishing to flatten the transparency, let us say your workflow allows only one getting your outputs to PDFX1A, even then you would need to flatten the transparency. But if you there also, if you put the text at the topmost layer, then the text will not get obviously flattened. It will be treated as a text, and it will be rendered as a text at the highest possible resolution at your rip, but everything else will get flattened at the resolution of the maybe 300 ppi or like that at in the design software. So this type of optimization you always must keep in mind while dealing with uh, the Z order, or while designing any particular object, right? So this is the first thing that I wanted to discuss today. The second thing that I would like to discuss is perhaps the grouping. That is why I showed you this. So let us say that this is an object. So let me make it a simple object. I'll not add anything over here. Instead, what I'll do is I'll remove the drop shadow. This is one object. This is a frame actually. This circle is a frame, circular frame, and I'll add some. Oh, sorry. I will add some drop shadow to the text. Okay. Yeah. So, I'll add some drop shadow to the text. This is what I added. Now, what I'm trying to explain over here is that, let's see, this is the frame which is having this circular object, and let us assume that, okay, let me just put them separately so that we'll be able to understand this concept clearly. Now, see, this is not within any transparency group or anything. Now, whenever you are creating a frame, right, whenever you are placing two objects within a particular frame as such, now within a frame, when you are placing two other objects, you must ensure that two objects do not overlap with each other. What will happen is, you see, this is a text which has got some transparency effect by means of a drop shadow over here, and this is another object which is placed in its vicinity. Now, the moment they overlap with each other, what is going to happen, if you remember our earlier discussion on transparencies, you would notice the moment they overlap, these two objects overlap with each other, although this circular frame or this particular object did not have any transparency effect, and it would have been rendered as such, but the moment you put this text, which is a ultimately a transparency object, together, I mean in vicinity or overlapping with the non-transparent object, this non-transparent object will also get rendered as a, or will also get flattened, even if it was not supposed to be flattened. So these type of mistakes should be avoided. Now, we the effect of flattening the transparency can lead to some different kind of a result, right? Because it is not, when you are flattening the transparency, you also saw in the earlier example, also in our earlier lectures also, when we are flattening the transparency, the ultimate result, visual result, might differ from what is expected, right? So it is always good practice. The best practice in this particular situation is, do not overlap them or don't, even if they are placed in its one another's vicinity, might be the design demands so, but don't overlap them until completely necessary. If you overlap any one of the object on top of the other, what is going to happen is, both of them will be treated as a transparency, and because they are overlapping, they will be rendered as a transparency. And if you are going to flatten it, both of them will be flattened, even if when there was not a necessity. Okay, so please keep this thing in mind. Now, the other example that I wanted to show is, now see, yeah. So see, this is one, how you deal with the different blend spaces, and what if there are different types of objects having different color spaces, and then one is having or overlapping on the other, and there is some transparency going on. Although I've discussed all this, but this is just an example on how to mitigate such problems, how to deal with such issues, and some of the best practices in the method of layout design. See, this is an image which is an RGB image, obviously, and this has got an embedded RGB profile with itself. Maybe this is Adobe RGB or something, and this is a YOLO. I think this is a CMYK device CMYK in space, and this might be YOLO in nature, right? So let me just check the color. Yes, so this is yellow. Yeah, this is process yellow, right? Now they are overlapping with each other, and not only overlapping, there's a drop shadow. So this has to be, when you are going to, convert it into CMYK, or even if you are going to flatten it, there will be a sort of color conversion. Now there is a problem here to understand. This is a CMYK device CMYK space. This is ICC based RGB space. Now, when you are, and one is overlapping on each other, so there is a transparency and there is a drop shadow as well. Now the question is, after converting them into their output intent, or after, while producing the PDF, what will these colors ultimately be? Because this has to be converted ultimately, because they're overlapping. If they would not have been overlapping, then they would have been rendered or created differently. I mean, differently meaning that the device CMYK would still be device CMYK, or converted to the output intent, and this RGB also would have been. Now the question is, here they are overlapping and there is some transparency effect. Then what is the color space that they are going to be converted to, because one is in device CMYK, one is in your ICC based RGB. In this context, or when these type of things happen, then you need to take care about what type of blend space, transparency blend space you are using. You already know about the transparency blend space. So when you go to under the edit menu, you get this transparency blend space. Normally when you intend your document to be printed, naturally that blend space would be set to document CMYK. That means your working CMYK, right? As soon as you select this document CMYK, no matter, and there is this situation, this particular situation arises, that there is overlap and both the images has to get color converted, then everything within this group or within this space will be getting converted into device or your working CMYK color space. No matter whatever ICC profile is there, everything will be discarded and it will get converted immediately into that CMYK during PDF production. Okay, so this is another thing that you need to take care. And so this is, we are talking about when your intention with the document is to print, but it may be that you don't want it to be printed, you want to produce this document for viewing in the web. In that situation, the same thing that you need to do is you need to go to the edit option, and under the blend transparency blend space you need to select this document RGB. This means that everything, including the device CMYK color over here, everything will get converted into your working RGB. So here working RGB is, I think, sRGB or maybe Adobe RGB, whatever it is, everything will get converted into that, right? So this is another thing that really you need to take care about, or remember that this is how it is to be done. Okay, so another example that I wanted to show to you is the reason for which I tried to put this color over here, this spot color over here. You see, this is a named color, Pantone 1108 coated, right? Now, whenever there is this concept of using any named color, maybe from the Pantone library or some other library, standard library, or some other named color in your artwork, you might think that it is right to convert them, this named color, to CMYK, but this is actually not true. Okay, what you need to do instead is, when you have got this library from I think Adobe CC onwards, they have supported all of Pantone's library within their design software. So you will get all these libraries from the swatches that is available to you. If you want, you can simply go to all the select a specific swatch and you can easily use that particular color from the specific swatch that you want in your artwork. But it is not recommended to convert this into your CMYK. I mean, the practice of converting Pantone or named colors to CMYK is not a good one, because then no matter, this is quite same as when you are defining your colors, you want your document space is CMYK, but you are defining your colors in RGB. So here let us say that this is a magenta color and this is 100% magenta, as you can see. But if I had defined this color as 100% magenta in the CMYK panel, but if I had defined this in RGB space in terms of RGB values, then I would not have obtained a perfect 100% magenta, right? This thing is the same for spot colors as well. Don't define spot colors in CMYK. If it is really a spot color from the standard libraries, it will be available. Now the question is whether you will be able to, for some purpose, let us say you have a 4-color machine and you are only able to print it in 4 colors and you don't have a 5th unit. So naturally the question of using any named color does not exist, and you need everything to be printed using the combinations of CMYK. In that situation, if you want really, I mean, if you've convinced your client and the colors appear to be okay during proofing, that your named colors or spot colors will be converted into CMYK. That is a separate issue. But again, do this during the design phase itself, because once you flatten your artwork, it is impossible to convert your spot color back to your named, to your CMYK composition actually. Okay, so this is not possible when we are working with a PDFX1A or GWG1v4 specification or workflow, because they don't support live transparency. As soon as your live transparency is not supported, then it is difficult or almost impossible to convert your spot colors back to CMYK when all the transparency have been flattened. But this is not a problem when you are using GWG 2015 or exporting your files to PDFX4 specification or standard. Then those PDFs support transparency. There it may be possible. There it may be possible, and it's sometimes it's also some uh, practice also. I saw a artwork a few weeks back. There were two patches. Both of them were magenta-ish. So one was, I think, some spot color, named color, and the other was some screen of magenta. So, and obviously they look different. So some the prepress operator was asked to match. The designer was actually asked to match both the colors. So one was, it's quite a difficult thing. I mean, one is a named color and the other is a CMYK. But this type of problems may occur when you are limited by your number of units. That is, only you have got four units, and you are not able to use the fifth unit. Only then this type of problems might occur. This is another thing that you should please keep in mind during layout optimization and creation of layouts. Okay. So in this part of the lecture, I will be talking about the idea that I already gave you earlier also, that what are some of the best practices when you are using some transparency groups or transparency objects. Now, the first thing is that you need to make the design as simple as possible. The moment you create or incorporate components that are very difficult to process computationally, then it creates a lot of problem. And also, keeping the transparency interactions as simple as possible can also help in avoiding certain problems. So the example that you see in front of you, see in the left hand side, this is ultimately a text, right? So this is in the left hand side, it has been created with 30% magenta. Okay, so this is opaque, 100% opacity is there, 30% magenta, and there is a drop shadow that is set with a transparency gradient, and over the box there is outer glow, and this is quite complex thing, right? But here what is needed really is prefer to design this as a 30% magenta screen with 100% opacity, instead of the one that I have shown you on the right hand side, where this is a 100% screen magenta but its opacity is set to 30%. So this becomes computationally difficult, and the more computational difficult it is, the more error prone the file will become, more problematic the file will become. You saw that earlier transparency example with the magenta background, and that's where rhodamine spot color background with the car in front. So how difficult it was to compute that. That is quite important for you to remember, that make it as simple as possible and try to find out or seek ways through which you can add. Obviously, if you want, if your design expects some transparency effect or special effects, you need to do it. There's no question about it. I'm not asking you not to do it, but I'm asking you do it smartly, so that these type of computational problems which might lead your file to cause some trouble, avoid those things actually. Okay. Second one, let me just yeah. So this is the second example that I wanted to talk about. See here, uh, in this context, another thing has to be kept in mind. So especially for the work that will be flattened before creating or generating the PDF, this should be kept in mind, and that is to avoid having any vectored transparent object like text that is partially overlapping with objects. So in this context, as you see on the that overlap on the bottom of the screen, so this here in this particular situation, here you would see that the text is partially overlapping with a transparent object, right? So this, whenever this happens, this is not very easy to be computed by the design software. So what you need to do in this particular scenario is prevent this from happening, right? Don't use this type of a design as possible. So this is quite similar to the that text with transparency and the object example that I showed. This is just the reverse of it. So there was a text with transparency and a frame which did not have any transparency, a simple object. This example is just the reverse of it. Here we have a text which is quite simple, normal, vector, and we have another object which is having some transparency to it basically. So when they are overlapping with each other, and overlapping how? Partially. For the first component it is okay, they are overlapping and all, but for the second example or the bottom example that you can see, they are partially overlapping. This overlap word that I have used over here, this is the single text matter, right? So this OVE and RLAP, these are not part of two different text, right? So they are partially overlapping with the transparent background you have. If this is to be flattened, let us say that bottom one is to be flattened before production of the PDF, then what is going to happen? This will be, you know, rasterized, and this will lead to kind of a fatter appearance. The part of the text which is rasterized, which is overlapping with the transparent background, this will appear to be more fatter, and this will not match the appearance of the non-rasterized text on the left. So this type of problems can occur. So what you can do? So let us say, another question you will ask me, so we can't use, so if my design wants this type of effect, so I can't use this. Yes, you can use it, but then separate this object completely and use all the uh, you know tools available to you to ensure the appearance seems to be same, or visually they appear to be similar. So maybe the text width needs to be increased for the non-rasterized part of the text, because as I already told you, if this is going to get flattened, then this will appear to be a little bit fatter. So that appearance you should match. Most importantly, you should separate these two text components altogether, right? So this is another thing that I wanted to talk about. Now another very important concept that I want to kind of get back into is the transparency blend space. So as you already know what the transparency blend space is, that how, if there are elements that are having different color spaces, ultimately how these colors are to be treated, and ultimately how these colors are to be converted. So that is what a transparency blend space is. If there are multiple groups and multiple objects having different color spaces and all, right? So this is that problem. uh, Here you must understand that where issues arise is when two or more documents are combined together, and where each has got a different blend space. So for example, if you are importing a Illustrator file in your InDesign, the Illustrator file has got a RGB blend space, let us say. When the InDesign file's blend space is set to CMYK, this will cause the problem. Here, try to think that these two transparent objects, the one designed in InDesign and the other design which is designed in your Illustrator, these when they try to overlap, the example that I showed you a while back, right? So one was in that image of the old man and the CMYK yellow patch. So when they will overlap together, so how will this be managed? What will this get converted to? So that is exactly the work of the transparency blend space. It is determining that how these colors which are having different kind of color spaces will be blended together, or you can say will be converted actually. Okay, so it is always recommended under the GWG 2015 specification to set your transparency blend space to CMYK, right? Now here the example on your left, here you can see this is actually an image. Here it has got an artifacts that can occur in printing when color spaces are mixed together up and have either been specified or improperly specified, and these transparencies are not quite similar one to other. The image on the left, this has been directly created from the Acrobat PDF Maker for Windows from a PowerPoint. This has been exported as a PDF from directly from PowerPoint. And in the process of creating the PDF, what happened? All the areas where the red, green, blue values are equal, that is the text and vector objects, are converted to grayscale. This looks quite okay when you are viewing it in your Acrobat Reader. I mean Acrobat or your Adobe Reader. Now when the file is printed, this is the effect. The right hand side of the image, the right hand side image is the effect of what the print is going to look like. So you see there are discontinuities and differences in the background rays and the blacks in the areas of shadows and reflections. This is caused because by this unnecessary page level transparency group with the ICC based colors of the objects of the ducks actually. So the ducks are having an ICC based color, but the background they are having a gray space, right? Gray color space. So this, and most importantly, the ducks have got these transparency levels, transparency effects. So they are, now you might ask that, okay, so ducks are not, the appearance of duck itself is not changing, or the frog itself is not. So what is changing really? See, the ducks have got, not only the duck is present, but around it you will notice that there is this kind of drop shadow effect, then this reflection type of stuff going on. So those are also actually made out with the same color space of the duck itself. So if your duck is made out of or has this ICC based RGB color, the drop shadow, the reflection, all of this also is having the same color space. So when this ICC based color space is interacting with the background gray scale color space, this is causing a difference of color. Naturally, when this ICC based color space is converted into gray and this background has got specifically gray only, so they won't match. And this is exactly the reason why this type of areas, specific areas, as you can see, they are getting separated or segregated, right? So this is the kind of problems that you can face while doing this. And so the question is how to correct this problem. Here you need to modify the PDF, manually actually, to eliminate any type of page level transparency group with this ICC based transparency, RGB transparency blending space. This, when you do this, ultimately, sorry, I think I had the picture somewhere, so let me just open that. No, I don't have that picture, so let me just go ahead and open that picture once, so that I can show you after editing what is the effect. Yes, so after editing this manually in your PDFs, where you have set the eliminated the page level transparency group with the this ICC based RGB transparency blending space, when you have done that, this is the result where which you can see that after editing, this is the result, and this looks kind of okay. And the differences in the background grays and the black which is in the foreground, that is ICC based colors, they have been eliminated and the prints have been rendered just fine. So this is another important idea that I wanted to give you. Now again, let me just come back to the concept of ordering, the importance of stacking objects and that Z order, and its relationship with the transparency, some of the best practices, right? Now, whenever you are creating this new object, it is always falling on top of the existing object. That is the normal procedure of how things work. This is that stack that I referred to, stack of objects, that all those objects stacked one on top of other. They are this particular thing, right? Now stacking this order becomes very much complicated and important when you are working with a group or a layer, and each of those have its own stacking order, and they can have various transparencies applied to it. Maybe they are applied differently for each of the object or a group of object or layer of object. So this is quite important, and this is where things can go wrong actually. As I already showed you, you can very easily change the order of the stacking stacked objects, either within a layer or of the layers in total, right? So transparency effects don't have to involve this overlapping objects, but this is often the case. So for example, when you apply an opacity value that is less than 100%, that magenta text that I showed, to lighten any object, regardless whether the object is in front of or back of the object. However, here by applying an opacity value, you not only make this object lighter, but it is also becoming semi-opaque. Now this causes it to blend with the object which is present below it. So that again becomes a transparency kind of that has to be rendered as a transparency instead of a text matter itself. Okay. When you're working of transparencies that overlap, one thing that obviously you should keep in mind is changing the stacking order can ultimately change the appearance. So that is the determining factor which object is going to be preserved and which is going to be overlapped. So maybe you are printing some opaque objects, where the opaque object or the object that you want to print on top of the other, that object is on is below the uh, you know object on which on top of which it is to be printed, right? Then naturally the appearance will differ. It will seem as if the object which is below it is overprinting or overlapping the object which is on top of it. So these type of problems can occur. As I already told you, again I will tell you that the text should always be placed on top of all other objects if it is not meant to interact with it. If now you can say that I want to overprint my text, I want to apply some transparency. That is a separate thing. But normally text matter has to be placed at the top. And placing text frames and spot colors on top of the stacking order, this will help them, uh, you know, uh, help keep them away from being involved in the transparency flattening. That effect that I already showed you. That why the reason why I kept those text matter, those yeah, these spot colors on top of the stack so that they don't interact with the rest of the transparency groups. There was some I created some knockout and drop shadows and all this. They don't interact with it and they are rendered separately, not within the transparency group. They will not be treated as a transparency group in total. Right. Another thing is transparency to create drop shadows. So drop shadows, as you already know, I have shown in the earlier example during the transparency also, that it is nothing but a soft edge mask actually that allows the color behind them to show through. And soft shadows are constructs that are not native to PDF and they must be created by the application itself. So that is, let us say in an image will be generated from the text which contains the actual drop shadow. So when you are let us say when you are seeing this particular, let me just go back and check if I have one such example. So let us say that no, this is actually, so let me just go back and I'll show you. So you remember how I showed you that example in the InDesign where that particular text matter had some drop shadow. So what is happening in the drop shadow is one image is generated. I think you remember this from the transparency lectures also, that one image of that drop shadow itself is being generated and that is treated separately, right? So the text itself and the image, they are placed within that transparency group as such. And the quality of such effects also depends on the bitmap generation. So it is always recommended that any drop shadow that you use and that has been created using this method are tested through a hard proofing method, so that you get the kind of, because this is ultimately a transparency and it will be treated as such, you automatically you should be able to see or visualize the effect whenever you are going to flatten it, because it is ultimately, as I already told you, that the text will remain as such along with the drop shadow image which will be grouped in a transparency blend group, right? So how it is appearing, this should be very much clear to you through, that is why getting a hard proof is always recommended. Okay. Yes, so this now let us discuss about another kind of a best practice that we should be following for color management work. So how to deal with the color conversions of different images that we are using. So primarily, as you can see in front of you, that there are three ways to do it of the color conversion work or binding. We say this to be binding. So this binding refers to when in the workflow colors are converted from RGB to CMYK. So for our example, so you should not confuse this with this binding that we often use in the pre-press, in the post-press finishing operation. So that is not to be confused with. But here when we are using the term binding, it means we are binding a specific color conversion from RGB to CMYK. So normally in our case we don't do the opposite, we always convert this, and doing the opposite is not possible. I mean it's possible, but I mean it's not right. I mean you shouldn't and you should never convert from CMYK to RGB under any circumstances for any purposes. This does not lead to any good result. So the concept here for binding is simple, that when at the workflow stage will I convert my images from RGB to CMYK. So when I'm talking about images, I'm only talking about photographic images. I mean digital images. I'm not talking about vector artwork or text matter, because they are only created in CMYK space. So no point in talking about them. The first thing that we can discuss is obviously the concept of your early binding. So what is this early binding? Immediately, so the designer itself or the editor itself, whoever is creating the design, that person himself is doing all the retouching and on the image in Photoshop maybe, and immediately converting the colors to color space to CMYK and attaching that CMYK color space image or placing those CMYK images in your layout software. So this is known as early binding. So this gives you a full control over what all the elements of color conversion by selecting the specific ICC profile, rendering intent, black point compensation, all of these things. But one thing here should be very much clear. I want to point this out quite clearly, that this should or this can be done only when you know your output partner. So in what situation you can do? Maybe you are a standalone designer, you have agreement with a certain print shop that for this year all my jobs will be printed and this is the thing, right? Under that circumstance, you know what is the capability and what are the printing conditions of your output partner. In that situation, there is a standard SOP maybe provided by your printer to you, and you know that they are printing to ISO quoted V2 300 maybe. So in that circumstance, you can immediately convert your image to your CMYK using the profile, and you have full control over how it would appear, right? Now, this is only possible when this type of a situation arises. But let us say when you are working as a standalone designer and you don't really know, have a fixed output partner, and the output partner may change, and depending upon the costs, you tend to move from one partner to the other. Now, in that situation, you don't know what the output intent of your partner is, your print partner is. So in that situation, it is not recommended that you convert the image from RGB to CMYK right at the stage when you are doing the editing, when you are editing the image in Photoshop actually. That in that situation, early binding is not really advisable. So in that situation, what you can do is go for an intermediate binding, right? So what is the concept of intermediate binding? You do the editing of your image in Photoshop and keep them in your RGB space, ICC based RGB space only. Now when you place these images in your layout document, then the images are converted to CMYK when the PDF is being created from the layout application. So what conversion is happening in the background? So the RGB, ICC based RGB space that the image contains, or that has been embedded within the image, that gets converted to the document CMYK ICC using the document CMYK ICC or working CMYK ICC profile. Here also you have full control over this process, because you are able to control the application settings and document color settings, transparency, blend spaces, what type of profile you need to select to convert the colors and all this. Then this much control you have over this process of intermediate binding, right? So what is the difference between early binding and intermediate binding? In early binding, you are doing the conversion, CMYK conversion right at the beginning, okay, but I mean while editing the image. But for intermediate binding, you are sending the media neutral file to layout software. There you are doing all the layout work and editing if necessary, while creating the PDF. At that time, when you are exporting the file into a PDF from the native layout software, then you are going for this conversion. And whenever you are going to export it in PDFX format, you know that there will be, I'll show you in the later stage also, there will be a output intent ICC profile. So using that output intent ICC profile, the image will be getting converted from the ICC based RGB space to the output intent color space. Okay, so this is what is the intermediate binding and how it differs from early binding. Next, we have got this concept of late binding. So here the RGB images are placed in the layout application and they remain in RGB even when the PDF is created. So as you know from PDF 1.4, and I think PDFX definitely supports all these type of color spaces, that is ICC based, your LAB and spot colors and CMYK obviously supported. So there is a possibility, it is possible for you not to convert those media neutral RGB files in your layout software even after creation of the PDF or during the creation of the PDF. So in the PDF that you created in this method, you will have the, I'll show you all this, you will have the opportunity to keep your RGB files, your images in RGB mode itself. Now to ensure that ensure proper color, all images are tagged, they are associated with individual ICC profiles. So the image that you are working with, that image should have an embedded ICC based profile or ICC profile itself, so that it does not get converted, right? If it's only a working RGB profile, working RGB space, it will get obviously converted to the output intent CMYK space. Only when it has got an embedded ICC RGB profile, then it remains media neutral even after the creation of the PDF. So the final conversion for the print is done by ultimately the workflow system in the printer end. Now, in this context, you have very little control over how the colors will appear after printing and the entire conversion process, because this is influenced by the settings of your RIP engine, of your workflow software. So like that. Okay. So both GWG1v4 and 2015, their data exchange, these processes are process specific. That is what I said earlier. So this means that while creating a PDFX compatible file using these specifications, then you need an output intent to be specified, right? Which is again an ICC CMYK ICC profile. Okay, this you should obviously keep in mind, but this is going to work, these conversions, I mean these RGB to CMYK conversions, as I already told, this works only for the images, not for the vector artwork or the text, because they're already created either in your CMYK grayscale or spot color. RGB images needs to be get converted to CMYK when the PDF is being created from the layout application, right? And converting images at the beginning of the workflow, that is early binding, this gives you a lot of more flexibility, lot more control, you being the designer. So you can see all the aspects after it is getting, or you can see the visual appearance of the image after it is getting converted. So this is more a conventional method. Why? Because it gives you a lot more control over the color appearance after it has been converted, and depending upon what reference printing condition you are printing your images to or your file to. Now, another important thing that the GWG recommends is what are some of the recommendations that you need to keep in mind while converting your images to CMYK. First of all, you need to use a relative or an absolute rendering intent. That is for sure. If you are going for hard proofing, you have to use absolute absolute colorimetric rendering intent. If you are going for soft proofing, you need to use relative colorimetric rendering intent. These are the only two rendering intents that are meant for exchange of data between proof and print, and I mean soft proofs as well. When you are using relative rendering intent, you need to use black point compensation obviously to get more of the shadow details, otherwise it will be lost. Everything in the shadow area will appear to be flat. And you need to include the ICC based RGB profile or ICC RGB profile if you are going to keep media neutral files during the PDF generation. And of course, when you're generating the PDF, you need to select the output intent, otherwise PDF X4 format or X1A, nothing will be successfully created. Even if it's created, if the output intent is something else, colors will appear to be different, it will be printed differently by your printer, right? So normally what the GWG recommends is to use an intermediate binding. So this enables the use of a single RGB image as a master file, and this helps reduce the errors, and specifically that are related to the conversion from RGB to CMYK. When to use early binding? If it has to be used, then image corrections of the CMYK image is required. So let us say you are a designer who want to you're not satisfied maybe with a previous print that your print partner delivered from your design, so now you want to make sure that the colors are of a certain nature, the appearance is of a certain nature, then you need to edit the converted image, CMYK converted image, so that ultimately after print that matches. And conversion needs to be done to a certain specific reference printing condition. And the third situation where early binding is to be done is when a source profile is used that creates a specific black or reflects the same underlying print condition. This is typically the case when documents are being exported from Microsoft applications or for textile reproductions, right? Now, when using intermediate binding, it's important to make sure that the correct color settings are used. Document profiles, the output intent, I mean, the export settings and styles are used the same throughout the workflow. And now intermediate binding also has got this advantage that RGB images are automatically converted to correct print conditions, and that is controlled by the layout document settings. It is not necessary to keep multiple versions or copies of the images for different output conditions. Using intermediate binding, this makes it easy to change the output intent of the PDF export whenever that is necessary. It is to be kept in mind that vector elements and text will always be prepared for a specific reference print condition. So this is quite important for us to remember, and now I have explained you the application, or you can say the reasoning or the rationale behind choosing a certain binding process uh, at the time of exporting your native design files to PDF during the preparatory phase. Okay, so hopefully this is clear.